hopefully you heard a bunch of terms there that we talked about yesterday, and it hopefully pulled some recollection up. Let's talk more about clouds today. Cloud formation. Before we get there, we need to talk about some things that hopefully you remember. What are the three phases of matter? Solid, liquid, and gas. Write it down. Plasma really only occurs on the sun, and are we on the sun? No. So water as a gas, which is actually water vapor, is invisible, but we feel it as humidity. That's why we've been learning so much about humidity with that lab and all of that, because it affects how you feel each day as you go outside. So on the next one, what do you think it is? Water as a solid and a liquid falls from the sky as precipitation. Oh, sorry. I asked the wrong question, not what was on your worksheet. Water as a liquid or a solid in the atmosphere forms clouds. When it falls from the atmosphere, it forms precipitation. Why do you have a blank look? Okay. I don't spoon feed you ever. Okay, and then I said write it down. So clouds are going to be formed both from water droplets and ice crystals. So keep that in mind. But first, again, we're going to talk about humidity because air temperature directly affects how much water vapor is in the air. We've talked about this ad nauseum. The warmer air is, the more moisture it can hold. The colder it is, the less it can hold, which means that when we are talking about like sweat on your skin and evaporating, warmer air has a higher rate of evaporation compared to the rate of condensation. What is condensation? Water vapor turning back into liquid. What causes the dew on the ground? Condensation, exactly. What happens is during the day, water vapor in the air and evaporation that causes water vapor in the air, yesterday we learned it was really, really humid, right? Okay, so all that water vapor is sitting there. What happens at nighttime? The temperature cools. Now, can cold air hold as much moisture as warm air? No. So some of that water vapor gets forced out and it becomes dew on the ground. That's why you wake up in the morning and the ground is wet, and we prefer you to walk on the sidewalks rather than through the grass so you don't track it in, right? So relative humidity, we've gone over this ad nauseum. Why do you think I keep repeating myself? Maybe because I know it's not a super simple concept, but I want you to get it. So relative humidity tells us how close the rates of evaporation and condensation are to each other. Basically, how big is the gap between where the water vapor will evaporate and where it will condensate. And when they are equal, the humidity is 100%. We learned that yesterday. When we walked outside, was the ground wet or dry? Wet. Had it been actively raining? No. But the ground was wet because the air was holding all of the moisture that it could. And so then anything that was trying to get back into the air was simply collecting on the ground as condensation. So what happens when the rate of condensation is higher than the rate of evaporation? The water vapor sticks together, and this is how we get a dew point. This is when dew forms, obviously, but it's also when we get clouds, mist, and fog. What did we have in the air yesterday? Fog. We've had mist quite a bit the last several days. So what happens at dew point? The water vapor sticks together and it condenses and comes out of the air. Now, we know that as air rises, what happens to the temperature in the atmosphere? Oh, come on. We learned layers of the atmosphere. Going from, just keep in mind, we're staying in the tropopause right now. Do you remember lapse rate? It gets colder, 6.5 degrees. Remember, per kilometer through the troposphere. Why are we focusing on the troposphere? That's where weather happens. Okay, you remember that part. So air cools as it rises in the troposphere due to the decreased air pressure. What's kinetic energy? What's kinetic energy? Mm-mm. Nope. Oh. Energy of motion. How in the world does air have motion? No. Oh, we've talked about this. It's so nice that you guys listen when I talk and I don't just say it to make my throat sore. Air molecules are constantly moving. That movement, that kinetic energy decreases as it gets higher up in the atmosphere because it's spreading out more. And so the temperature drops as you go up. And here's the thing. Maybe this is something you did not know. Clouds need something for the water to condense onto. Completely pure water is actually going to have trouble condensing because it kind of needs a little kickoff point. So this is called condensation nuclei. What's nuclei? The plural form of nucleus. What's a nucleus? The center. Okay. It's literally just a center, a tiny particle that the water forms around. This can be dust, pollen, salt, smoke, anything else that rises up into the air. If the dew point is below freezing, what's the dew point again?
When water sticks together and there's so much humidity that it can't hold it.
Okay, so it forms dew along with fog. If the dew point is below freezing, what temperature is freezing? 32 degrees Fahrenheit. The water vapor deposits as ice. That makes sense, right? Okay, if it's below freezing, that water becomes ice. So they changed the name to freezing nuclei. It's the exact same thing. It's just a matter of whether or not the water is water or ice. I can tell you all are just riveted by this. Sometimes water vapor can remain in a liquid state well below freezing, especially when the atmosphere is considered quiet. If you may or may not have experienced this. I actually had a student last year that said they've seen this in action, where their dad left a water bottle in the car overnight. It dropped below freezing, but the water did not freeze in the water bottle until he picked it up, and that tiniest bit of agitation, the water bottle instantly turned to ice. What that means is the water is below freezing, but it hasn't found something to freeze around because it's been too calm. And as soon as you agitate it, it freezes. So there are clouds. Haha. Here's the thing, and this is why this matters. There are clouds where this happens. And this matters because when the airplanes fly through the clouds, do you want the agitation of the airplane wing to cause ice?
Yes.
No. I prefer to make it to my destination alive, thank you. Alive. I'd like to enjoy it.
What if it's a work trip?
Then I'd like my husband to come home safely. So, airplane companies know that there's always a possibility of those super cooled clouds, so they use de-icing chemicals to prevent that freezing from happening on the airplane wings. Now, I saved you all a whole lot of writing, but you need to know these cloud types. So what we are going to do is we are going to start at the top of the troposphere and work our way down with altitude you will notice that there is a pattern. Each altitude has different types of clouds based upon their shape, their potential to cause rain, and their altitude. So higher up in the atmosphere, you have cirrus. Cirrus clouds are those thin, wispy clouds. Sometimes they're called horsetails, or mare's tails, excuse me, because it looks like the hair of a horse's tail. Then you have cirrocumulus. Cumulus are always puffy. But when you combine cumulus and cirrocumulus, you get little puffs, okay? Well, this is called a mackerel sky. What's a mackerel? A fish. What do fish have on them? You just said it. You just said it. Scales, exactly. It looks like rows of scales. And then you have cirrostratus, which are sheets. All stratus clouds look like a sheet of ice crystals. So, key thing to note here, if you need to circle it on your chart, do so. The clouds in the upper part of the troposphere always start with what prefix? Cirro. Then you're going to have cirrus, which are wispy, cirrocumulus, which are puffy, or cirrostratus, which are like a sheet. Okay? Then we move down into the middle troposphere. What's our prefix there? Alto. So here's the thing. They don't put alto in front of cumulus at this point, but you need to know that cumulus are alto level. Oh, I didn't have that long.
Sorry to interrupt.
Nope, you're fine.
What's up, everybody? So we're handing out tickets to all students to go see Diary of Anne Frank Thursday, Friday, and Saturday. You can redeem these tickets
Don't trip.
any one of those days. It doesn't matter. You can do whatever you want.
Now, please keep in mind let's see, I know some of you have some younger siblings. Keep in mind that this is a more mature play, and that's why they're not doing a matinee. Matinee is when they did the performances in the middle of the school day for us, and the whole school got to go watch. But the story of the Holocaust is not appropriate for my little first grader to know the horrors of it. You know, I can teach him an age-appropriate way, but this dives in pretty. Not. Huh? They just chose to give you tickets. I actually already bought a ticket.
Oh, you did?
So I bought myself and my husband a ticket because I didn't know I was getting a free one.
Works for us.
I was gonna say, you got an extra what, $12 for the drama department. All right.
See everybody. Come watch the show.
Yes. Okay. Yeah. Owen's in it. Go support your classmate.
I'll go do it for me.
All right. Yeah, Owen. That's right. Owen and Manny are characters. Owen and Manny, you play characters, right? And Lauren, you are crew. Okay. Okay. All right. I know, like, of all the people to cast as a Nazi, you know, Manny is who I would choose.
Hey,
Sarcasm, dear. Okay. We are moving on. We are not discussing the play. We are going back to clouds. I know. So cumulus clouds are white and puffy. These are the ones that really, like, they raise really high up from their base. Notice they can be associated with fair weather or light rain or snow. Obviously, how are you going to tell the difference? Okay, let's try this again. If it is 70 degrees, you are going to end up with what? Light rain or fair weather. If it's 30 degrees, it's going to bring snow. And you guys are well aware that when it has a lot of When there's a lot of rain associated to it, what color are the clouds? Dark. Okay. So then we have altocumulus. Notice they are different from straight cumulus. These look like huge tufts of cotton. This, you've got little puffy, again, a little bit like that mackerel sky again. What? There you go.
How are they not how are those in it?
Because of their altitude, which you're not going to be able to tell just by looking up. But scientists can tell the difference because of their instruments, and it means a different thing with the weather, yes.
That'd be kind of cool.
That is.
That's where we
How,
get
what is the
raw.
average weight of a cloud?
It weighs more
They
than
never
Considering
weigh
I'm telling you 9 different types of clouds, 10 different types of
The
clouds.
average weight of a
No,
cumulonimbus.
no,
The average weight of one
like
cumulonimbus can
3
go
billion
over
million
the height of
1.3.
Anyway, yes, Manny.
So sometimes, like after a storm, I'd see these clouds that look like cotton balls.
Hmm.
Those altocumulus.
Are you saying they looked more like this or they looked more like this?
They look more like the alto.
Okay, then yeah, that's probably altocumulus. And like I said, Case asked a good question. The only difference, because they do look very similar, is the altitude, which you're probably not going to know by looking. As for Atticus's question, I don't really know.
Would you drown
Altostratus. Shh. Shh. Altostratus, again, this is going to be a middle cloud that is a flat sheet. Notice those are going to be gray. And it does say light rain and snow. Now, the lower clouds, you have stratus, so low layers of those gray, flat, sheet-like clouds, light to heavy rain. These are usually the ones that are going to accompany fog. So with knowing what we've had the last couple of days, would you stop shaking the table? Knowing what we've had the last few days, what kind of clouds have we had?
them.
Whatever you're pointing at.
So wait, what are the ones that said like
Stratus.
What
Hold on. Now, stratocumulus are low and dark. They're flat on the bottom, but billowy on the top. You can see there's a little bit of billow there. And they can come with light to heavy rain. And then you have nimbostratus, which are low, dark layers again. Notice those look very, very similar. The key thing there is they are low and they are gray, so you should automatically know they are some type of stratus cloud. Yes.
Is them the ones that
Well, hold on, because I
Yes.
think it. No, I don't think those are. I think it ties to these. Cumulonimbus are the ones that start really low and have a flat bottom, really low in the atmosphere, and billow up really, really tall. These are the ones that bring thunderstorms, rain, hail. Would you stop? You're sitting there making that noise right by the computer. If you're going to fidget, fidget quietly.
Stanley, is your microphone there?
Yes, it is. You scared me for just a second. Okay, thank you.
The room, the cumulonimbus clouds.
That's what I was thinking.
Okay. Notice that
Cumulonimbus.
notice that this says vertically developed clouds are the ones that are cumulo. So cumulonimbus, vertically developed clouds that bring rain. Going backwards, stratocumulus, there's that build vertical. We continue to go backward. Altocumulus, there's that vertical build. Cumulus, there's the vertical build. So just remember, cumulus are puffy, like big billowy cotton balls, because of how they grow upwards. So in Hank's question, Hank, go look out the window. No, go look out the window. Hold on, Gavin. Look up in the sky. Describe the clouds that you see.
One's bright, the other one's dark. and it's between some of them and,
Are they flat? Are they wispy? Are they billowy?
I don't know.
She said
Cloudy.
Girl,
They're billowy.
They're not
They're
any
white.
of the
I don't know.
cumulus.
Oh my goodness.
Cloudy. Very cloudy.
I'd say
They're
they're
not-
alpha cumulus.
They
Mine
have
are like
liquid in 'em.
blend in.
Water.
no.
I don't know the definition of billowy.
So kind of billowy.
Go look at.
What colors are they? They're kind of a grayish. Gray tends to accompany the low level clouds. Low level clouds. Maybe God thinks they're pretty.
Yeah, that's what I was thinking.
Strato,
But like,
stratocumulus. Okay. As a non-expert, I would label those as stratocumulus because you can tell by the color that they're lower in the atmosphere, but they are billowy. Yeah, it doesn't quite have the rows like this, but it is more billowy than just a straight stratus cloud. So moving on. Okay, this one's a short video.
What are the different types of clouds? Clouds are often one of the first things we notice when we look up into the sky. They're all
There we go. Okay. Shh. We are not going to make it the rest of the way today. We will talk about precipitation tomorrow. What, Eli?
you know, like the clouds and rain that Dusty went up above at the very end. What were